Okay, good morning, everybody. Thanks for joining episode 2 of our Net Zero webinar series. My name's Keith Everett and I work within the sales team here at EA Technology. For anybody who wasn't able to attend episode 1 of the series, I'll just do a little recap of, who we are, the webinar series itself, and sort of lead into what we're talking about today. So for anybody who isn't aware, EA Technology are a UK-based company based in Cheshire. We're specialists in asset management solutions for owners and operators of electrical assets. So we were originally founded back in 1966 as a research and development organisation, really, within the nationalised UK electricity network at the time. So since privatisation, we've of course been able to continue that kind of R&D thesis internationally, working with clients on a long-term basis to safeguard the power networks, innovate and advise on strategy and implementation solutions. And in addition to that advice and the consultancy services we offer, we do also provide a wide range of products across both hardware and software solutions to improve network safety and reliability, as well as supporting long-term strategies such as net zero. So the idea behind our Net Zero webinar series is to just break down different topics associated with net zero, the challenges, the solutions around the drive locally and globally to achieve those net zero targets, which, as we all know, is a very hot topic in many sectors at the moment, but it does focus heavily on electrification, using clean energy solutions and changing the way in which we live our day-to-day lives to the benefit and the planet, and future generations. Now, of course, that does, as we know through modelling, put a lot more stress onto the electrical infrastructure that we have in place, and a lot of the work that we've been carrying out for the past couple of years and continue to do so is around supporting that infrastructure, whether it's on a private network, an operator's network, whether it's local individual business, net zero challenges, things to do with design, through M&E businesses and consultancy and all that kind of thing. So we've designed each episode to be sort of 30 to 40 minutes, trying to provide information in an overall headline fashion without getting into too fine the detail. And the hope is that this will engage people to relate this information into their own lives, their own business challenges, in a way that helps their understanding of the topics and their own net zero journey. Now, of course, if anybody does, wish to get into more detail and get into those finer points and have discussions, then myself, our panelists, and the wider business would really welcome this. And we can support you on an individual basis with the knowledges and the resources that we've got available. So please do ask questions during the webinar. We do have the questions tab. You should have that available to you on the controls. And if you'd like to contact us separately, then please visit the website, eatechnology.com, and you can use the contact tab on that page to get all the relevant details to contact us, and we will, of course, respond accordingly. Anything that we aren't able to answer today through the sort of time that we have for the webinar, then again, we'll take that offline and we will contact people separately. So episode 2 is focused on EV charging, which, as we all know, is a very, very hot topic. EV car sales are increasing year on year. Locally, countries are feeding this into their own individual strategies, but there are a lot of challenges around that subject. One of the largest of which is the infrastructure needed to provide public, business, and private charging points to allow EV users to utilise their vehicles in a fairly seamless fashion as they travel around their day-to-day lives. And I think we all know we're not there yet, and that can be one of the blockers to sort of people moving into an EV car. So we're going to sort of look at some of the things as to some of the data around this and some of the ways in which we're helping people to sort of overcome that challenge, not just on a company basis and a network operator basis, but resources that are actually open to the public as well in many areas at the moment, and we'll be continuing to roll that out with other operators across the UK and internationally. So I'm going to be joined today by Dr. David Mills, who's recently joined the business, and I'll let him introduce his role and talk about that in more detail. Esther Dudek is from our consultancy team, and we'll talk more on EV charging and new connections. We're also joined externally by Lawrence Chittock from PTV Group, and they've been instrumental in supporting EA Technology to develop software solutions to help people across all walks of life map EV charging points using information from the relevant network operators here in the UK. So although these segments will be recorded, I'm not going to hide that, it'll be fairly obvious when we play it. They do join me as panelists, so they're on hand to answer any questions, and we will keep the webinar open once the videos are finished for any further Q&A. So without any further ado, I'll introduce David, and we'll play these videos.
Hi, I'm David Mills, and I head up the Net Zero Transition team within the Consultancy Insights division of EA Technology. I recently joined EA Technology from a background in power networks consultancy to take on this exciting new role to lead a team of passionate engineers focused on supporting the decarbonisation of the energy sector. My team works alongside the rest of the consultancy business with a focus on providing advice across the energy industry to help overcome challenges and come up with innovative solutions to accelerate the decarbonisation journey. We work with generators, developers, networks, end users and local authorities to address some of the challenges that need to be tackled to achieve net zero. To do this, we bring together experience working within the electricity networks globally to provide analysis, advice and recommendations on how some of the challenges can be overcome. The focus of this webinar is on the impact that the net zero transition has on new connections. We're all aware that there's an accelerating focus on decarbonising the energy we use for heat and transport, and with a significant shift of that being through electrification. There's always lots of talk around the need for more charging points to support the growth of electric vehicle, and as more and more EV charging stations get built, the number of connection requests for electricity will continue to increase. Added on to this, the government is looking at opportunities for decarbonising heat and recently announced the sale of gas boilers is going to be banned in new build properties from 2025. Instead, it looks like there's going to be a significant amount of heating and hot water demand coming from electricity rather than our current gas infrastructure. So with the acceleration in EV uptake, along with the decarbonisation of heating and various other net zero initiatives across the energy industry, it's inevitable we're going to need more generation to support this continued increase in demand. As EA Technology and within the consultancy business, we've delivered a lot of projects looking at various opportunities and approaches that can be applied to better manage the EV charging infrastructure and operate the distribution networks more flexibly. But at some point, the same consensus gets reached. We're going to need more renewable generation, we need more interconnection, and that therefore is going to require more connections to the system as we have decentralized generation and we look to decarbonize our transport and heating systems. The distribution and transmission networks represent the part in the middle. They get the electricity from the generators to the houses, businesses and industries that need it. Historically, those networks have operated passive systems in such a way that power flows from the large generators through the transmission system to the distribution networks and then eventually into our houses. However, over the last decade, it's been gradually shifting. We've seen more and more renewable generators connecting into the distribution system, and obviously in the continued growth in domestic level generation, solar panel uptake, as well as domestic battery storage is starting to see a growing increase. This is all completely changing the way we use our electricity and how the networks are having to operate, having to accommodate new energy usage patterns, growing demand, as well as generation levels. and networks that were never previously designed for them. This is all leading to a need to better understand how electricity is used on the system, increase levels of monitoring, forecasts and analysis to make sure we can use and keep those electricity networks operating. Now, the electricity industry has been continuously evolving and testing new technologies to improve monitoring on their network, making sure they understand the impact of low carbon technologies and what those are going to have, and developing alternative approaches to replacing cables and transformers that already exist. We don't want to see all of the roads dug up, every single cable replaced with a bigger cable just because we're looking to use electricity rather than heat. Where we can, we want to make sure we can make use of those existing assets. As we continue to decarbonise, there's going to be even more demand for electricity, more connections to distribution networks, and continued development of innovative approaches to getting connected and keeping the lights on when we need it most. Thank you for this brief introduction to myself and the Net Zero Transition team and some of the work that we're helping to support the energy industry. The rest of this webinar is going to focus on some of the challenges that as a team we've been working to address across EA Technology and making sure we can continue to support the acceleration of connection of new low carbon technologies onto the distribution networks and the net zero transition.
Thanks, David. My name's Esther Dudek and I'm part of EA Technology's Innovation Delivery team, working on projects and software products which facilitate the connection of new loads like EV charging infrastructure to electricity networks. Today I'm going to give a little bit of context on the challenges that electrification of transport could bring and show a couple of the tools we're developing to address these, particularly in the connection space. The first graph shows us some background of where we've come from on the emissions from transport since 1990 in the UK. And you can see from that that there's been minimal progress towards achieving the carbon reduction emissions that we need to. You can see there's clearly a lot of work still to be done. So one of the key ways that transport carbon emissions will be decreased is through electrification. That's shifting the energy we use for transport away from fossil fuels like petrol and diesel and towards electricity that we can generate from renewable sources. The graph shows the projected makeup of energy demand for transport out to 2050 by different fuel types. You can see that petrol and diesel use, the yellow area, declines and electricity and hydrogen increase. You might also be wondering why the energy consumption is going down as the fuel mix changes. And the answer to that is that electric vehicles are considerably more efficient than the petrol and diesel models they replace. So electric transport is also going to reduce the amount of waste because they're using about a third of the energy of their petrol and diesel counterparts. The electricity industry has known that this new load from transport electrification is coming and has been working to prepare for that for over a decade now through various means. There's lots of examples on the slide of what's going on, but essentially what they boil down to is understanding what that new demand will be and where it's going to have impacts on their networks, developing technologies and systems to help accommodate that new demand, and upgrading networks and also modernising systems and policies to help facilitate that uptake. The part of all this I'm focusing on today is about particularly how we can improve the connections process to make it quicker and easier to get a connection. The components of electricity networks have all got a finite capacity that's based on their material properties. So when a new load is going to be connected, like an EV charger for instance, that increase in load could cause that asset to go above its thermal rating, or could mean that the voltage on a network is too low because you've got too much volt drop. When a customer wants a new connection or they want to increase the capacity of their existing connection, they've got to submit an application to the network operator called the DNO. The network operator undertakes an assessment to determine if that new load can be connected without breaching any of the network limits. Now, there are challenges with the connections process as it stands. To get a budget estimate for a connection, the customer has to submit information to the DNO. They take that information, go away, do the necessary studies, and create a budget estimate and send that to the customer. Now, often that budget estimate is enough for the customer to be able to help narrow down their location or understand if a particular site that they're looking at is viable. Now, at the moment, generating that data, sharing it with the DNO, them doing the assessment creates burden on both sides and also takes time. Now, challenges with the connection system is not new, and they particularly came to light as customers looked to connect solar generation over the last 5 to 10 years. That generated a lot of connection requests. And EV charging infrastructure presents a similar set of challenges, and network operators are looking for ways to improve the process to benefit their customers. I'll highlight a couple of the examples that we're working on. The first one is auto design, and that's available now for Northern Power Grid's licence areas in the North East and North Yorkshire. We'll share the link to auto design, and it can also be accessed by scanning the QR code on the screen. It's a public-facing connection tool which generates budget estimates for a range of different connection types, not just EV charging. The public can use it to look at different options for where they could get a connection, and it also saves DNO planners time on quotes which don't progress any further because the customer's already narrowed down their choice using this available information. I'll walk through the steps in creating a budget estimate in auto design. So the first one is to narrow down the location. So in this case, putting in a postcode and also saying what it is you'd like to connect. And we use this to work out the capacity of the connection that's being requested. So is it a house or bungalow or perhaps flats or EV charging, and how many? With that information then, the map layer appears and it shows the existing network and where the user can connect based on that connection capacity they've requested in the previous stage. So you can see on this map that there are some areas where a connection is possible in green and some where it isn't in the red, and some areas where we don't have the data necessary to complete that assessment. Now you can see from that actually the customer wouldn't need to move their connection very far in either direction to make the difference between being on a red section or a green one. And it's this type of information that can help the customer narrow down their choice of location. The next step asks for some slightly more detailed information. So what the customer's asked to do here is just draw a polygon which shows the boundary of their site and then connect that up to the existing network. So you can see here connecting onto a green section. And this information is used to generate the budget estimate because we know, for instance, how long that trench needs to be and what type of ground it's going through. So once we've got that information, it then creates the budget estimate, gives the customer an estimate price and also a reference number if they want to take that further and consult the DNO. Our second example is ConnectMore, and we're developing this for SP Energy Networks as part of the Charge project, which is a network innovation competition project that we're working on. And this is preparing Merseyside, North Wales, Shropshire and Cheshire for the electrification of transport. Now, what's different about this project in particular is that it's bringing together both transport planning and the distribution network to look at how we can align those two things because of transport electrification. ConnectMore is an interactive online map, and you can see a screenshot of the beta version on the screen. It's available on SP Energy Networks website now with the link there and also the QR code. You can see here we've got two main parts of the tool. So EV charging demand, this is using a transport planning model to show where the demand for EV charging is likely to be into the future and some characteristics of that demand, and also electricity network capacity. So you can see on a single map where there is high demand for EV charging and also where the best places are to be able to get a network connection. So this gives a treasure map of good locations for chargers. This shows the EV charging demand layer, and you can see here is the heat map, which shows where demand for charging is highest, and that can be configured by the user to look at particular charger types, different locations like destination chargers or residential chargers for people who don't have off-street parking. And also the user can select different scenarios and move through the years from 2025 to 2050. Now, as well as giving the heat map, The tool can also produce more detailed information for individual packages of land around what's the total energy demand for EV charging and what speed of charges are needed here. Lawrence will talk more about this next. The other layer that's available now is visibility of the available capacity on the LV network. For this, the user can select different amounts of new capacity depending on what they want to connect, and the map will update to show where there is good capacity to connect that new load, with green areas, perhaps limited in yellow and poor in the red. Now, ConnectMore is still an ongoing project and is in development, so we have more features that will be coming soon. So that includes visibility of the available capacity on the HV network for larger connections, that's things like rapid charging hubs, the ability to generate cost estimates to get a connection once you've entered all that information, and also being able to view smart charging connections options. So where it might not be possible to have an unconstrained connection, then it might be possible using smart charging. Thanks everyone. I'll pass you on to Lawrence, who'll talk more about the transport model and ConnectMore.
Thank you, Esther, and welcome to my talk on planning EV charging infrastructure. My name is Lawrence Chittock. I'm a transport modeller for PTV Group, and we develop modelling software for the transport planning industry. This software is used by many clients, including DfT, regional and city authorities, to plan and assess transport schemes in their area. In the context of charging infrastructure planning, we've looked at how modelling transport demand can help assess the requirement for the number of charging points and the demand for electricity. So why is this important? Well, lockdown effects during 2020 aside, transport is the highest CO2 emitting sector in the UK. The energy sector, on the other hand, has been decarbonising at a much faster rate, and so with cars shifting to electric, the transport sector can effectively piggyback on the success of the energy sector. For us to meet net zero targets, however, it's vital that this transition happens fast. During the recent COP conference in Glasgow, many countries committed to accelerating this uptake and announced programs to increase the rollout of charging points. But how many do we need, and of what type and where? And what can electricity networks do to prepare? To be able to assess future electricity demand and the requirement for their infrastructure, for the first time it is necessary that network operators understand mobility patterns. In doing so, they can plan upgrades for their networks, implement flexible services, and be able to cope with demand peaks associated with electric vehicle charging. Transport models are digital replicas of the transport system and have been used for several decades to understand how systems operate, how people move about, and how roads and public transport services should best be operated to cope with demand. Using this technology as part of the Ofgem funded Charge project, PTV have developed a transport model to forecast how electricity demand from EVs might grow and how this demand might be distributed spatially and temporally. Detailed data about where people live, why they travel, and how they move across the transport system has been used to build up a picture of mobility patterns in the area. In this case, modelled car trip patterns have been used to inform how EVs might move in the future, where they might be parked, and how much electricity they will require based on their travel patterns. This transport model for the Charge project has been built to cover the SP Energy Networks ManWeb region and includes a full representation of population, land use, transport networks, and mobility patterns. EV uptake has been modelled in 4 different scenarios and 6 forecast years. Patterns from these vehicles has been used to inform where EVs might be driven and how this translates into the demand for charging. Driver profiles in our model have been modelled down to an individual level to understand how the accumulation of trips creates demand for charging. In this example, an EV driver who is assumed to have a home charging point travels from home to work, then on to the shops, and then back home. The next day, they travel to see friends before driving on to a recreational destination and eventually returning home. At any stage, charging infrastructure could have been used to replenish their range, either at home, at the destinations, or as a stop-off en route. Thus, the requirement for infrastructure and the resulting electricity demand has been modelled using a combination of hard constraints, such as the range of a vehicle and trip distance, and soft constraints. That means where a vehicle will need to recharge, but the choice of where this is done is open. These softer constraints have been informed by observed charging data from today, and then varied based on discussions in a series of scenario workshops discussing how the market might grow. The results from the transport model have been integrated into the ConnectMore website that others have spoken about, alongside data on current electricity network capacity. This data is freely available and can be used to understand how demand for different types of charging might grow over time at a detailed local level. By overlaying this information with network capacity data, users can identify hotspots of where infrastructure is needed and where capacity exists to install new points. Please go and take a look at this tool, and the link is at the bottom of this screen. While the tool can be used to support local decisions, I'd also like to share some of the insights for the whole region. For each modelled scenario in each year, our model estimates the demand for EV charging split by different location types, as shown in the top right on the screen. In our on course for net zero scenario, for instance, we envisage that demand for charging will increase fivefold between 2025 and 2030, and will then double again by 2035. This scenario is based on plausible growth in EV numbers that sees us keep in line with net zero emissions targets. It's therefore necessary, if these targets are to be met, that electricity networks and infrastructure suppliers prepare for this significant growth. In particular, we estimate that the need for public charging will grow as more and more people without driveways get an EV. And because some of these people have the ability to charge at home or work, and some will not, the spread of charging demand will vary significantly across the region. In Liverpool, for instance, which has many terraced neighbourhoods, the requirement for public charging will be high. Charging points at work, retail, other attractions, and forecourts will therefore be needed to satisfy this demand. In Chester, on the other hand, more properties have off-street parking, and we envisage EV uptake to initially be higher in these locations. Public charging, however, might not be needed so much by the locals, and should therefore cater to those coming from Liverpool or further afield. And this bit in how different customer groups will have different charging needs is further echoed in other findings. In particular, we can expect Pareto-like effects, whereby most EV drivers will be able to charge at home, but actually most of the demand for public charging will come from those without a home charger. Our models roughly estimate that by 2030, more than 65% of public charging will come from the 20% of drivers that cannot charge at home. So therefore, understanding the demographic of car owners without a driveway is key to planning for public infrastructure. So to wrap up from me, I'd like to emphasise that understanding trip patterns is crucial to assessing future charging patterns, and consequently the planning of charging infrastructure and electricity networks. The models developed in the Charge project provide an estimate for energy demand at a detailed spatial and temporal level, and can be used to assess the need for public charging alongside electricity network capacity data. Do go check out the ConnectMore online tool, and thanks very much for listening.